Okay, today we're going to talk about absolute maxes and mins, which we saw earlier. We saw the question about this earlier in one of your quizzes, and I told you that to hold on, that we would spend a whole day talking about that, so today's the day. So we're going to look at solving problems involving multiple rates of change still, but then adding to that how to find an absolute max or min in that context. Before we do that, though, let's kind of refresh what we know about the definite integral. We know that if we have the definite integral of a function, that's the way the problem looks, and I'm being asked to integrate from a to b f prime of x dx, and I know that that's going to give me a numerical answer, and I know that that numerical answer represents the signed area between f prime and the x-axis. And I also know that that number represents something about f of x, or the original function, not just about the derivative, because I know if I integrate a derivative, I go back to the original. And what it tells me is change in the y values on f, or the original function, between a and b, so f of b minus f of a, or change in y values. On f. And you'll remember earlier this week we kind of drew both of those, what's really going on. So if this is my graph of f prime, then the definite integral is this space. If this is my graph of f, then the definite integral represents how much the y values grew. So it's this distance here. So it goes from being an area underneath the derivative to representing kind of a one-dimensional change in y values on the graph of f. Okay, let's look at our first example problem. The first bit of it will seem familiar. Then when we get to this question, we're finally at the question where we're being asked about a maximum. When is the number of people on the subway system a maximum? What is that maximum value? So I notice here that I'm being asked about number of people, so I probably am going to need to integrate. And then a maximum. So I'm really looking for absolute maximum here, because I want to know when are there more people on the subway than at any other time. So that's an absolute maximum. And I have kind of a process for finding absolute maximums. I identify endpoints and critical points, and then I make a table. So I'm going to do that exact same process, although the details of it work out a little differently. So the first thing I'm going to do is come over and start my table here. And I know that my endpoints are time 0 and time 12. That was given to me in the problem. Those are always the easy ones. Now I need to figure out my critical points. And I know that my critical points are where the derivative equals 0. And in this case, I don't have a derivative. I have two parts to that. I guess I do have a derivative. I have two parts to it. I need to consider entering and leaving. So I'm looking for where the overall rate of change, or E of t minus L of t, I'm looking for where the derivative, the overall rate of change of the function, is equal to 0. I have those in y1 and y2, so I can just come down for ease sake and put y1 minus y2 in y3. I'm going to do that. And then I'm just going to look at a graph of it. And I'm going to do second calc 0 in order to find the times at which this y3 is 0. Don't try to trace to find those. You might can get some idea of what they are, but trace is not specific enough. It will give you an approximate answer, but not an exact. So I'm doing second calc and then choosing 0. And I have to kind of bound in my zeros. I'm going to do that. And I find out I have 1 0 at time 4.7928, so 4.793. And then I have a second 0, and in order to get to that one, I'm going to use the arrow key and arrow over closer to that 0. The calculator always finds the 0 it's closest to, and so I need to get closer to the 0 that's on the right side of my screen. And I find out that that 0 is 9.370 to 3 decimal places. And then here, I'm trying to maximize the number of people. So here, I need to figure out, well, how many people are there at those times. So I know here, and this will be in thousands, I know at time 0 there are 5,000 people, because I was given that. Now I'm going to use the formula, I think it was number 2, the formula I had in number 2. I know that the number of people is 5 plus the integral of n minus the integral of out. So I'm testing those at 4.793, 9.370, and 12, just using Math 9 and then adding 5. At 4.793, I find that there's 7.358, so 7,358 people. Now I'm going to test 9.370. And at that time, I find that there are, I keep forgetting to add 5, so don't forget to do that, 7.033, so 7,033 people. And now let's check for 12. And at time 12, there are 7.779, so 7,779 people. So there is a maximum of 7,779, or you could say 7.779 thousand people at t equals 12. That's the same way we've been writing maximums all along. That works just fine here as well. Okay, let's look at our next example. Our next example is graphical. Okay, here we see a problem presented at least partially graphically. So this is a new situation. We've seen these problems mostly with algebraic formulas. So reading through here, we have people calling in for tickets, so they're joining a call queue. There are 300 people waiting on hold when the processing starts. So there's my initial amount. There are 300 at before I start answering the phone. The operators can handle 400 calls per hour, so there's my out rate because they're removing those people from the queue. The graph at right, consisting of 4 straight lines, show the rate C of t at which new calls are coming in. So this is my N rate, and it's presented graphically. And we're going to start answering calls at 8 a.m., and we're going to assume nobody hangs up. Okay, so I'm going to make a note here that my out rate is 400 people per hour. My N rate is C of t there, and I have 300 people initially. So question 1 asks me just how many people call in between t is 0 and t is 6. So I need to integrate from 0 to 6, just my N rate, because the question is just about how many people call in that time period. And then I have to think, oh yeah, I haven't seen this in a while. If I need to find the definite integral from a graph, I need to calculate areas. So I did that. And I found out that the area between 1 and 2 is 600. I just divided it into a rectangle and a triangle. This space is purely rectangular, so that area is 700. Notice each block is worth 100 because it's a x change or a time change of 1 and a y change or a calls per hour of 100. So 100 calls per hour times 1 hour gives you 100 new people in the queue for each box. This up to 3 is 550. Between 3 and 4 is 250. And between 4 and 6 is 100. And again, I just did those by calculating areas, dividing things into rectangles and triangles. So So there we have it. So the integral from 0 to 6 then is just the sum of all those areas. So 600 plus 700 plus 550 plus 250 plus 100 gives me a total of 2,200 calls, or 2,200 people call in. My second question is the number of people who are waiting on hold increasing, decreasing, or staying the same. So I see the language here, increasing, decreasing, which tells me, this is a rate question. I should not be integrating. I just need to consider in rate minus out rate. So in minus out, no integral, between hour 1 and hour 2. So I need to consider C of t between hour 1 and hour 2. And then my out rate's a constant for 100. So if I look anytime between hour 1 and hour 2, I can see that my end rate is 700. I'm just reading, I'm not finding an area there, I'm just reading that Y value. So the calls are coming in at 700 calls per hour in that time period, being processed at a rate of 400 calls per hour. That gives me a positive 300 left over. So the number of people on hold is increasing, since my overall rate of change is positive. And in fact, I could even, if I wanted to be really specific, say it's increasing at a rate of 300 calls per hour, which seems like a lot. Question 3 asks me, at what time is the number of people on hold the greatest? So there's a keyword meaning, I'm looking for a maximum here, looking for an absolute max or min, because I'm looking for when is the absolutely the greatest number on hold, and then how many are on hold, so what's that maximum. So I know that I need to find endpoints and critical points and build a table. I'm going to try to build my table horizontally here. I don't have a lot of space to build it vertically, so I need T and then the number of people. And I know I need to include 0 and 6. They don't specifically tell me to stop at 6, but that's as far as I can go because that's all I have on my graph there. At time 0, I know there's 300 on hold, so I can get that one for free. And then I need to figure out, okay, well, what are the critical points here? And I remember that my critical points are where the derivative equals 0. So that's where in minus out equals 0. So that's where C of t minus 400 equals 0. But now I can't just graph it on my calculator and do second calc 0 because I have a graph of C of t, not a formula for it. So I'm going to have to do something with that graph. It might be helpful to me thinking-wise if I rewrote this equation as C of t equals 400. That makes it a little easier for me to figure out what I'm trying to do with that graph. So I'm trying to look for where, this is the graph of C of t up here. I'm trying to look for where on that graph, where is C of t 400? So I'm just reading across the line there for where y is 400, and I see that it's at t is 3. So in some ways maybe easier, once you figure out what you need to do. So 3, and that's the only place where the end rate is 400. So that's the only place I have to check. And now I'm calculating the total number of people at each of those times. So I'm taking my initial amount, which was 300 people, adding to it the integral from 0 to 3 of C of t, subtracting from that the integral from 0 to 3 of 400. So the integral from 0 to 3 of C of t is 550 plus 700 plus 600. So just adding up the areas and then subtracting off the integral from 0 to 3 of 400, which turns out to be 1200, and I get 950. I'm going to do the same thing at 6, so my initial value plus, I already know that C of t from 0 to 6, I found it in number 1, so plus, that's 2200, plus 2200 minus 400 for 6 hours, so 2400, and I end up with 100 people on hold at time 6. So they're about to get through the queue by time 6, but I can see my maximum is here. If I had space to write it, I would. I would say a max of 950 people at T is 3. Then my fourth question here is to write an equation involving the integral of C of t whose solution gives the earliest time k when there is no one on hold. And so I know that my number here is the number of people on hold. So if no one's on hold, I want it to be equal to 0. And then I know the number of people is comprised of the initial call in, the integral from 0 to some time k of C of t. That's my number in minus my number out. And there I have my expression. We've written several of those, but this is the first time we've seen the where no one or where it reduces down to 0. In some cases, some of the problems, it doesn't make sense to make it equal to 0, but in this case, since they're asking me when there's no one on hold. Notice that it says write but don't solve. You'll see that pretty often just as a time saver so that you aren't spending hours on the calculator. Okay, that's it for today. Go take your quiz.